test is already up. I took the bonus questions off. You got 2 times to take the test, takes the higher of the 2. And we're going to start on chapter 2. Now, as we start on chapter 2, 2.1 is just algebra, so I'm not going to go over that because y'all should know it, so you can work on the homework problems as you see fit. 2.2, we actually start with the derivatives, and here are the derivative rules for logarithms, so go ahead and write those down. They're on the right-hand side. Of course, most of you probably already know them, so we're just going to spend a little bit of time writing them down, and then we're going to get started. You can write the ones on the left down if you want to, but the ones that I'm concerned with are these right here. Also add to that the antiderivative of e to the x is e to the x. So you can also add d dx of e to the x is equal to e to the x. Okay, you'll see these on the slides, so I'm going to go on to the slides. So, the first derivative we're going to learn is the derivative of e to the x. E to the x is written just like that. The only thing you got to watch out for with e to the x is the chain rule. Example for the first one. Y is equal to 3e to the x. So y prime would be equal. You can pull the 3 out because that is the constant rule of derivatives as well as antiderivatives. And you can just work with the e to the x. And the derivative of e to the x is e to the x. So therefore, your answer is y prime equal 3e to the x. Now, while this seems very simple, if you have anything else but an x up here, it changes the whole problem. Okay? If I have a 2x up there, you got to revert back to the chain rule. If I have sine of x up there, you have to revert back to the chain rule. If I have a negative x, you have to revert back to the chain rule. Next one, y is equal to x squared times e to the x. Product rule, y prime is equal to x squared first times the derivative of the second plus the second times the derivative of the first. That'll be x squared e to the x, 2x e to the x. You can factor out an e to the x, and that's going to leave x squared plus 2x. And that's how you do that. The next one, using the quotient rule, or you can bring this up, and that would be x to the negative third. And that's going to be, first, let me erase this. Of course, you already know how to do that, so I'll just erase it. So we've got y is equal to e to the x times x to the negative third. And of course, that's going to give you something totally different. Or you can use the the quotient rule. Let's use the quotient rule. It might be easier. And that's going to give you denominator times the numerator prime plus minus the numerator times the denominator prime. So that's going to be 3x squared over denominator squared, which would be x to the 6th, and that's going to be x to the third e to the x minus 3x squared e to the x over x to the 6th. And you can factor out x squared e to the x. Let me make that smaller. I can't make it smaller, sorry. Let me go back. I don't want to show you the answer yet. There we go. So that would, I'm going to go to the top. So you can factor out x squared e to the x, and that's going to leave what? X minus 3, right? Yeah, x minus 3 over x to the 6th, and that'll cancel that to a 3, right? No, cancel it to a 4. And that's going to be e to the x times x minus 3 over x to the 4th. And that's going to be your answer there. So here you've got just basically e to the x, then you've got the product rule, then you've got the quotient rule. And you see there's the answers. And there's the answer there. I don't know, let's see, x squared e to the x, that's the second one, b. And that's what we got. I think I factored out e to the x. And then the third one, there's the answer right there. They factored, and yes, they got x to the 4th. So there's 3 good test questions right there. Next, differentiate between 6e to the x. 6e to the x, that's going to be 6 parentheses e to the x, which is equal to 6e to the x. I feel like we're doing the same. Is this the same problem? Are these the same problems? Oh yeah, that's right. Y'all not going to talk to me, so we'll just keep going. I don't need to go over the same problems twice. So we'll just keep going. All right. If I have something other than e to the x, then I've got to do the chain rule. So what do we do here? Y is equal to e to the 8x. So therefore, y prime is equal to e to the 8x, okay, and then times 8. So y prime is equal to 8e to the 8x. Here, y prime is equal e to the negative x squared plus 4x minus 7 times negative 2x plus 4. And c, let's put c down here. Let me just draw this. C, you've got e to the x squared minus 3 to the 1/2 power. So that's going to be e to the x squared minus 3 to the 1/2 power times 1/2 x squared minus 3 to the negative 1/2 power times 2x. And then you would use your algebra. The 2 would cancel with the 1/2, and you'd be left with e to the x squared minus 3 to the 1/2 power times, that's going to be 1/2, that's going to cancel, that's going to be x times x squared minus 3 to the negative 1/2 power. Your answer there. And you can check those answers. You might can reduce that one down a little bit more. I don't know if they put the -1/2, they might put that on the bottom. So 8, that'd be negative e, got that, 8e to the x, that's what I've got. X squared e to the negative, that's going to be e to the negative, I can't see it, but let's see, I can't move this over, I can't move it over, but anyway. And there's that one. They did bring the x squared minus 3 down to the bottom. Next, they're going to check those. Okay, now find the second derivative. Second derivative, first derivative, let's go ahead and find it. So that's going to be y is equal to e to the negative 5x squared. That's going to be y prime is equal to e to the negative 5x squared times negative 10x, and that's going to be y prime is equal to negative 10x times e to the negative 5x squared. That's your first derivative. Second derivative is going to be y double prime, and that's going to be first times the derivative of the second. We've already taken the derivative of the second right here, so that's going to be e to the negative 5x squared times 10x, negative 10x, plus the second is negative 10x, times the derivative of the first, and the derivative of the first is going to be, I'm sorry, I just went off there. Hold on. I was just looking at this. I wasn't looking at this. I meant this. Let me make sure I did that right. Negative 10 first times the derivative of the second plus the second, there we go, plus the second e to the negative 5x times the derivative of the first, which is negative 10. And now that's going to be y double prime is equal to, you're going to multiply that 10x times 10x will be 100x squared, 100x squared e to the negative 5x squared minus 10 e to the negative 5x. You could, I think you probably might factor out a negative 10, maybe, or 10, but I'm not going to worry about that because that's algebra. So there's your double prime. So chain rule, and you're going to get first derivative is negative 10x e, I think that's what I have right there, e to the 5x squared. And the second derivative is going to be, let's see if I got what they got. Okay, that's it. So is that what I got? I think they factored out a 10 e to the negative 5x squared. So they factored out one step further. Questions so far? Okay, Fishing Emporium invested $50,000 in an account that earns 1.25 annual interest compounded continuously. The value of the account after 2 years is given by this. They want you to find A5, and then they want you to find A prime of 5. So I'm not going to worry about A5. You can do that. And I'm going to go ahead and take the derivative. So the derivative here, you can do 50,000, pull it out. You get A prime of t is equal to 50,000. And then break that out, and you get e to the 0.0125 t. And then I'm going to take the derivative of that. So that's going to be A prime of t is equal to 50,000 times e to the 0.0125 t times 0.0125. And somebody you got your calculators handy, take 0.0125 and multiply by 50,000 for me. What do you get? 6,250.
Oh, wait. Sorry, I did 0.125.
Okay, do it again, please.
625.
625. Heck, I ought to have you teach in the class. 625 e to the 0.0125 t. And now you can plug in that 5, and that's just algebra, so you don't have to do that. I mean, I don't have to do that since y'all know it. Next. And there's your answer, or I think they've got the answer. When you plug, that's the first part where you plug in 5, and then they get the second part. And I think there it is, 625e, and then you crank that in and get 665. Okay? Here where we have the derivative of there, and then the chain rule. So that's the summary of what we just went over. So let's go to 2.3. Hold on a second, I'll pull up 2.3. I thought I had it pulled up. Any questions? So 2.3, or was that 2.3? That wasn't 2.3, was it? I thought it was 2.2. 2.3, yeah, there we go. So natural log and logarithm are the same. Y'all know that. It depends on what you have. But there is the first rule of logarithms. Okay? The derivative of the log is 1 over x. So make sure you write that down. So everybody got that written down? So 5 natural log of x. Y prime is equal to 5 times 1 over x, which is equal to 5 over x. Here we have sum rule, but we also got the chain, I mean not the chain rule, but the product rule right here. So here we're going to have y prime is equal to first times the derivative of the second plus the second times the derivative of the first plus 4. Okay, because that's the sum and difference rule. And then you're going to have y prime is equal to x to the third over x plus 3x squared, natural log of x, plus 4. And this cancels and you get what? X squared, I think, right? So y prime is equal to x squared plus 3x squared, natural log of x, plus 4. Here, use the quotient rule. I'm going to bring the quotient rule over here. And that's going to be denominator times the numerator prime minus the numerator times the denominator prime over denominator squared. And that's going to be x squared divided by x is x minus 2x natural log of x. No, that's going to be natural log of 2x, sorry. Natural log of 2x over x to the 4th. Next. And there's your x squared plus 3x squared, natural log plus 4. And the last one is going to give you x squared, natural log of 2x, 2x, natural log of x. Oh, I forgot the x. Sorry about that. Natural log of x times 2x. Should be an x right there. My bad. And they just, I think they're dividing through by x. Or did I do that? Okay, there's x squared right there. There should be an x right here. Make that change right there. And then you can factor, that's what I was trying to do. I was trying to factor out x. That 2x goes there. So you could bring that 2x. So it'd be x times 1 minus 2 natural log of x. I'm sorry, I'm running out of room. Over x to the 4th. That should be your final answer. Let's see what they get. X minus 2x They didn't factor out an x, but you could if you wanted to. There it is. X, 1 minus 2 natural log of x over x to the fourth. Okay? And here we've got the natural log of f of x. This is your chain rule. So you got to be careful here because this is the chain rule with, and that's du over u. Okay? So that means that when you do the natural log, what do they do? Okay, here. Natural log of 3x. Okay? So let's go ahead and do that one. So y is equal to natural log of 3x. So that's going to be y prime is equal to 1 over 3x. I'm sorry. 1 over x. 1 over x times the derivative of what's inside would be 3, which would be 3 over x. So that's number 1. Now we're going to have to do the second one. And that should be 3, and say dy is equal to 3. What are they doing? I did the 1 over 3x. Oh, I just forgot the 3x. My bad. 3x, and then, okay. So I've got, oh, they're doing b there. I did a. Okay, they did 1 over x, 1 over 3x. That should be a 3x. Sorry about that. But y'all probably already knew it anyway. I can't get anything to erase on this stupid board. There we go. There. Now I did it. Okay, so natural log of 3x, you got to take the derivative of 3x. So that would be 1 over 3x and then times 3. There we go. So y is equal to natural log of 3x, which would be y prime is equal to 1 over 3x times the derivative of what's inside, which would be 3 over 3x, which would be 1 over x. There we go. I'm sorry, I missed that 3x. And here we've got the product rule, the natural log of the natural log of x, and then here we've got the quotient rule. And when you do the natural log with the power rule, with the product rule, let me see what there it is right there. Of course, I've got everything written on top of it. There's 1 over x squared minus 5. There it is right there. I'm sorry. I went to C. There's x squared minus 5 times 2x, and there you get 2x over x squared minus 5. I want to get to C. There. So if you take the natural log of the natural log, basically this, if you take this and you use the product rule, you're going to get 1 over the natural log of x times 1 over x, because the derivative of this is this, and the derivative of the inside is 1 over x, and that leaves you with 1 over x natural log of x. And then you're going to use the quotient rule here, and that's going to give you the derivative of natural log of x cubed plus 4 minus the natural log of x, and of course then you get 3x over x cubed plus 4. The natural log of x is 1 over x, and then if you wanted to, you could get a common denominator, or you could cancel, you could get a common denominator and cancel out what's left. And that's what they did. So, questions so far? Good. I've never seen a class get stuff so easily.
But could you slow down, please?
Say again?
Could you slow down, please?
Oh, I'm sorry. Are y'all communicating with me? You need me to slow down?
Very much so.
Oh, okay. Well, I'll slow down a little bit because I'm not going near as fast as other teachers do. In a psychological experiment, students were shown a set of nonsense syllables such as POK, RCD. This is not a test question, but they're going to want you to take the derivative of RT. I'm not going to read all that stuff, okay? So, first of all, I would write it negative 27 natural log of T plus 80. What percentage of students retain the syllables after 1 minute? They want you to plug in 1. I'm not worried about A. You can do A. Find R of 2. So go ahead and do that. Go ahead and find the first derivative and plug in 2. Y'all can work on these logarithms over the break. Yes.
I took the test yesterday because I felt ready for it.
Good.
And it's a little different from the other ones. Like there's no time and there's no limit to each question.
I fixed it.
Okay.
Yeah.
I just didn't know if that was on purpose.
No, I made a new test because I had to take the bonus questions off, and I had to make a new test, so I fixed it, and I forgot to check those 2.
Okay.
Yeah, I saw where you took it. Good job. And I tried to make the test for 45 minutes to an hour, and I think that's how long it took you, about 40 minutes, I believe, so that wasn't too bad. All right, so here we go. If we took the derivative of R of T, then I'm going to rewrite it first because I don't believe in writing it like that. So R of T is equal to negative 27 natural log of T plus 80. And of course the 80 would go away because the derivative of 80 is what? 0. So that only leaves this right here. So R prime of T is going to equal negative 27. I'm going to pull that out. And what's the derivative of the natural log of T? 1 over what? T. So that's going to be negative 27 over T. And somebody plug in 2 for me. And that's going to be negative 27 over 2. I don't know what they want, but that's the answer. That's when you plug in just the number they asked you to plug in. And then take the derivative, and that should be negative 27 over T. Did I have a negative in front of it? I think I did. And negative 27 over 2. Okay, so whenever you take the derivative of 1 over x, the derivative natural log of x, you're going to get 1 over x. And when you have the natural log of the f of x, you do u over du, or du over u, sorry. You take the derivative of that function and you put it over the function. Okay, so you might want to write that down. A lot of people in calculus say du over u. And you might want to write that down because it's easier to remember. Du over u. I can't write. I can't work the board either. I got corona. Du over u. Meaning that you take the derivative of the function, put it on top, and leave the function on the bottom. So that's about 3 or 4 rules of logarithms. Wow, that was quick. So let's go back and let's see what the next section is. Probably going to be, let's go with That's 2.3. Let's go with 2.4 next. Yeah, we already, well, that's applications. Let me go to 2.6. We'll do the applications last. 2.6. There we go. First of all, when you have the derivative of objective, they ain't got it written the way I want it. Where's the way I want it? There it is. The derivative of a to the x power. So let's go 2 to the x power. If you have 2 to the x power, then it's going to be the natural log of 2 times 2 to the x. So an example here, a good example, would be 2 to the x. F of x is equal to 2 to the x power. If I want f prime of x, then that's going to be 1 natural log of 2 to the x power times 2 to the x. Oops, 2 to the x. And you could rewrite that natural log of 2, sorry. So that would be the answer you would be looking for, and that's when you get 2 to the x. Now, when we get to antiderivatives, and when you solve an equation with 2 to the x, you're going to take the natural log of both sides, and that's why you need to know how to do the natural log. That's why, especially in differential equations. There's, I don't believe it. I can't believe I just chose the example. There you go, natural log of 2 times 2 to the x. And these are pretty simple. And if you have the chain rule, then you have to remember the chain rule is involved. And so that one would be 1.4 to the x. So that would be the natural log of 1.4 times 1.4 to the x. So 1.4 could actually come out front. This 2 to the x could come out to the front. That really doesn't matter. So that's going to be natural log of 1.4 times 1.4 to the x. Here, it's going to be the natural log of 3 times 3 to the 2x plus 1 times 2. They kind of threw the chain rule in there on you. They threw the chain rule in there and didn't tell you. Okay? There's the 2 right there. Remember, if you have something in parentheses, you've got to take the derivative of what's in parentheses and just add a little set of red parentheses here. Whatever's in those parentheses, you've got to take the square. You've got to take the derivative of. So they kind of slipped that one in on you. So that's a quick check. That's just what we did. Oh, these are the same? Yeah. So that one would be natural log of 5, 5 to the x. Natural log of 4, 4 to the x. Be careful, natural log of 7, 7 to the x squared times 2x. There's 2x at the end. So that chain rule kind of helps out, but it also gets you because you forget about it. Theorem 13, 1 over the natural log of a times the natural log of x. All right, that's when you have log base a of x. You're taking the derivative of log base a of x. Now that's different from what we were doing before. Before we were doing log base 10 or log base e. Y'all remember the change base formula? When you have a different base? Well, this is what happens when you have a different base. You have to take the log of that base and put a 1 over it, and then the log of x. It's kind of like the change base formula. The change base formula says if I have log base anything of a number, then I'd change that to log of 10 of that number over the log base 10 or base e of x. That's algebra. That's change-based formula. Here, you're taking the derivative of a different base of a number, and it's the same thing. See, they take that base, they put it right there. They take that base, they put it right there, and then they take that number, and they put it right there. So it's kind of following the change-based formula that you learned in algebra. Okay? So let's look at one. So that's going to be 1 over the natural log of 8 times 1 over the log of 8 times 1 over the log of x. Oh, okay, I thought they were going to do it. Well, let's go ahead and do the first one. So the first one is y equal to log base 8 of x, and that's going to be the differential is going to be y prime is equal to, and that's going to be 1 over 8, natural log of 8, or log of 8, times 1 over x, which is equal to 1 over x log of 8. And let's see what they got. They're doing it. Okay, they use natural log. You can use log or natural log. Okay, B, let's do B. B is, this is log base 10. Okay, that's log base 10, so that would be the natural log of, or you could do 1 over x, but I think they're trying to show you that you could do it with the 10 by saying natural log of 10, right here, 1 over the natural log of 10 times 1 over x, which is equal to 1 over x natural log of 10, which would be the natural 1 over x, should be. So, natural log of 10, they didn't carry it on further. And then that one, I'm not going to go back and forth, so here's the third one. And that's where they take the 1 over the natural log of 3. And then, what is the derivative of x squared? 2x. So that 2x slip up on you again if you don't watch out. Remember, if you have something in the parentheses, then you need to take the derivative of it also. Let me go back. And the last one, x to the third, you got to use the product rule. So that's going to be first times the derivative of the second, plus the second times the derivative of the first. The derivative of the second is going to be, write this down, I'm just going to write it down because I'm not going to do all the other. So that's going to be the 1 over natural log of 5 times 1 over x, which would be 1 over x natural log of 5. And that would be first times the derivative of the second plus the second. That's going to be log of 5x times the derivative of the first, which would be 3x squared. Okay, so you're going to have some kind of, so that's going to be x cubed over, and that will cancel. So it'd be x squared over natural log of 5 plus 3x squared log base 5 of x. And actually, you could use the algebra, the change-based formula, and you could change this to the log of x over the log of 5. They might be doing that on the next problem. They might do that. You could change this right here to the log of x over the log of 5. So that's something you think about also. So let's see what they did. Okay, log of 5. No, they left it right there. So they had the same thing I had. Questions so far? There's just some examples right there. So write those 4 examples down. You can work on those too. let's do the first one. So that's going to be 1 over natural log of 2 times 1 over x, which is equal to 1 over x natural log of 2. And then that -7, you could actually pull that -7 out. You could do the product rule, but the product rule, the -7 derivative would cancel it out. So if it's whatever you want to do, that's going to be -7 over, or -7 bracket log of x. The derivative of log of x is 1 over x. So I think you're going to get -7 over x. Okay, on that one, let's check that one because that one can be tricky. What did they get there? 1 over natural log of 2 times x. And natural log of 10 over x. They did use the natural log of 10, but that will cancel out and you'll end up with x, 7 over x. They're just not doing it right there. And then here, let's go back and do that one. I want to go back and do the one with the chain rule. So here we go. So g of x first times the derivative of the second plus the second times the derivative of the first. No, that's not the chain rule. The d is the chain rule. And then crank that out. Now, you could also use 1 over the natural log of 10 times 1 over x. You could use that. It'll eventually work out. And here, we're just going to do the natural log, 1 over natural log of 8 times 1 over x to the third minus 7. And what's the derivative of x to the third minus 7? 3x squared, and you're going to put that 3x squared on top. Okay? And I think that's what they got there. Yeah, there's the 3x squared right there. Okay? So you see these natural logs and logarithms are not that difficult. Let's see, this is a recap of what we just went over. So y'all got 3 or 4 sections to work on. Any questions?
I don't.
All right. Y'all have a good break.